So we're going to be able to determine if a number is in scientific notation or not. We will be converting from standard form into scientific notation and the other way around. And I'll do the do now with you. So we have to write 10 to the negative fifth in two different ways. Hopefully you remember negative exponents can be rewritten as positive exponents. Remember, negative exponents represent our fractions. So this is 10 to the fifth power. If I wrote it another way, I could write it as 1 over 10 times 10 times 10 times 10 times 10. I could even write it another way. This is equal to 1 over 100,000. Of course, all fractions can be written as decimals, so it's the decimal tenths, hundredths, thousandths, 10,000ths, 100,000ths. It's the decimal 0.00001. And the only thing I really want you to notice is that powers of 10 have like a trick to them. This exponent of negative 5 actually represents how many decimal places there are in this number. 1, 2, 3, 4, 5. 5 decimal places, and that's why it's to the negative fifth power. So that's how we can write things in scientific notation. The reason why it's called scientific notation is because it's used a lot in science. Scientific notation is a way of writing very, very large numbers or very, very small numbers so that you don't have to write all those zeros out. So this number is in scientific notation. The exponent of positive 3 shows that there are 3 decimal places to the right of a number, and this exponent of negative 5 shows that there are 1, 2, 3, 4, 5 decimal places before this number. It all relates to a number that's between 0 and 10, between 1 and 10. This number is allowed to equal 1, but it has to be less than 10. So both of these fit the scientific notation rules. What I like to think about is that I need one digit that's either 1, 2, 3, 4, 5, 6, 7, 8, or 9, then a decimal point, then there might be some other numbers after it. It then gets multiplied by 10 to some power. This power is positive when the number is very large, and the number is negative, the exponent is negative when the number is very small. Now, when I'm talking about very small, I'm talking about a decimal number between 0 and 1. When I'm talking about very large, I'm talking about a number greater than 1. So this number can be written in scientific notation. If I use the format that I wrote down, I want one digit and then a decimal. So I put an arrow where I want my decimal so that I could start writing it. I want it in the form of 8.63. I don't have to write a 0 at the end. I need to multiply it by a power of 10. This power, since this is a large number, will be positive, and I just count how many decimal places from the arrow to where the decimal point really is. Remember, in a number, if you don't see the decimal point, it's at the end. So if I count, there's 1, 2, 3 decimal places. This is scientific notation, and it is mathematically equivalent to 8,630. You could do the calculations if you wanted to. This is 8.63 times 10 to the third, so 8.63 times 1,000 does give me 8,630. I honestly would never do the calculations because the reason for using scientific notation is to use the trick that with powers of 10 you could just move the decimal place. This is a very small number. To put it in scientific notation, I need one digit. Remember, this first digit, let's write down a little bit more, has to be the numbers 1 through 9. So that's why I want my decimal point right here. I want the 4 and then the decimal point and then the 2, 6. I multiply it by 10 to some power. This power will be negative because it's a small number. This is a number between 0 and 1. I count how many decimal places from the decimal to the arrow, and there's 1, 2, 3. Therefore, this is a negative 3. and that is how you do scientific notation. So the objective said we'll be able to determine if things are in scientific notation. This one is. This one's not because of that plus sign there. Remember, it's supposed to be multiplied by a power of 10. This one's not because of this number here. The decimal is supposed to be after the 3 to be considered scientific notation. This one's not, again, because of this number. This number, I told you the number before the decimal is supposed to be the numbers 1 through 9, so this is too large. This one is scientific notation, and this one is scientific notation. So hopefully you can tell when something's in scientific notation or not. So my video is almost done. I know it seems like I'm going fast, but we have shortened periods today. So next page. We have to convert these numbers to scientific notation. I would go put an arrow where I want the decimal and then write the number with the decimal in that spot. And then I would multiply it by a power of 10 by counting from the arrow to where the decimal is. 1, 2, 3, 4, 5, 6. This goes to the 6th power. In exercise 8, I want the decimal here after the 3. So 3.04 times 10 to the, this is going to be a negative exponent because it's a small number. Count from the decimal to the arrow, 1, 2, 3, 4, 5 to the negative 5th. You guys can finish this page without me. I'm just going to do one more thing on the next page. So now we're going from scientific notation to standard form. So what I first notice is the exponent. It's positive. So this has to be a very large number. So I want to move this decimal to the right to make it large. So I write the number out without the decimal. I put my pen where the decimal is, and then I count what the exponent of the power of 10 says. 1, 2, 3, 4, 5. And I fill in the gaps with zeros. And there I go. That's my answer in standard form. I don't care that this number is negative. I keep the negative there because I look at this power, it's positive, so I still have to move the decimal to the right. 1, 2, 3. So that's what it becomes. If I were to do something with a negative exponent, like this one, I write out that number. I put my pen where the decimal is, and then I count 3 places to the left because this is a small number because of the negative exponent. 1, 2, 3. Darken in your decimal. Fill in the gaps. This is a number, tenths, hundredths, thousands. This is a number 400 thousandths. 4 thousandths, I'm sorry, 4 thousandths. And then you can finish this page on your own. Let's see what this is. So you're just using this chart to write things in scientific notation. And your homework is this page, page 25. In class, you must finish up whatever problems we didn't do for class. If you finish your classwork early, you can then start on your homework. So there is extra help tomorrow morning if you need it. And I hope you enjoy the rest of your day. See ya. Bye.